able to add them, break them, like do untold things to them without messing with the replayability of proof scripts. That's why we do everything in terms of this have tactic that we've used a ton here, and why induction takes the consequence. And one of the reasons for that is that I want to be able, we generate properties for something like this. So if I introduce an M such that not M is 0, I kind of want the proof context to just say there's an M that is a natural number, and it is such that X is 0. So I can't quite, I have to be a bit careful about that and not prevent me from so I want to be able to abstract types. So we don't want to say that all the variables in a proof context have as their type a simple sorry. What a week though. So we don't want to make it so that they have to be representational types. They need to be refined types as well, or to have the ability to be. But they would probably at the end be either a representational type, or a type where atoms are abstract types, so to speak, irreducible in a certain way. I'm not exactly sure how we want to play this. And it can add a ton of things, I have a function from a quotient to a quotient, so it would naturally add this property of being respectful of quotient equality. But I'm still scared of quotients. I don't know how I want to deal with them, because they will mess up everything. Congruence closure, will have to be extremely careful when we talk about equality. Needs to be typed somehow, and that sounds like a recipe for disaster. I haven't thought this out, so we'll see. For the time being, let's give us 2 full screens like this. There's a lot of, the printing here is horrible. I think I might not want to print these, but I don't know how to do this right now. So this is the proof for this. Also very long. It's not very useful for me. I'd probably want to remove this, but I'm not exactly sure how I want to do this. Probably be easier when the program syntax and the where do I print these? Really? It's something in. So what do I call? What is my function? So this program is called example, and what do I call an example? I call check program. So let's look how check programs work. I see. An axiom takes a maybe proof, or what does it take? We can change these. axiom doesn't, it's theorem that I care about. And it's a maybe tech out, which is, so I want nothing tech out, basically. So this one, I don't need the decal, I think. Let's check. No, we don't call it again. So I can remove this. I don't think I need this actually. And here I do theorem ZP nothing tech out. Yeah, that is much cleaner. So we're not printing the tag text, but there's no point to that. We're just saying briefly what we've written and what we've proven. You can see here we have here only, like in this theorem, we haven't proved. So maybe we should start with that to figure out what we want to do. So we want to say that, I don't know why it's called div1, probably because I had no imagination at the time. In this one, we have one of the goal that is proved automatically, so it has two green ticks. The yellow tick here, which you might not be able to read very well, it's not a tick, it's a cross. It means that it hasn't been discharged automatically by the standard tactic. And therefore, I had to prove it myself. The second tick says the tactic script worked. And this one, there's two ticks just because I was lazy to do better, but there should really just be a one tick here. Just like there's there, because it's an axiom. So I'm trying to prove what div of times nm equals t. And that, okay, so that is the same as these other axiom, and I want to prove that they're the same. That was where we were actually. So one of the things I've been thinking about is focusing. That's why it is in the title of this stream. Is it readable? I think it's fine. So this is LGF. It's a focusing discipline for intuitionistic sequent calculus, which is more or less what we are working with here for no other reasons. That's what I'm used to work with. We can actually use a bit more space, I think. So maybe we can fill yeah, that's all of it. Okay. So, it gives me a number of things, like it lets me put a hypothesis here it's on top. There's not like, it's compact but not extremely readable. But the point is that this is a hypothesis that has been selected and I can do stuff to it. So all of these rules that have something on top or below it, well, the below are less interesting to me, really, I think, for this application, because there when we focus the conclusion, which is something that I will allow us to go in and out of. Like, I don't care about focusing the conclusion, I think. In a number of ways. I'll explain in a second. So when something is on top, we can apply transformation to it without naming it. It's just the thing. So we can refer to a proposition by its type, put it on top, and let it and pass it arguments. So that right now things work fine when we have the ability to unify. We just unify things, discharge a couple of things. We do a very simple thing, but not necessarily. So when something is here, we can just pass argument to it, and possibly eventually we could implement the automatic tactics as finding arguments automatically. I'm not exactly sure what I want to do with this. So we reach an implication. We say, okay, so we can just prove one of them and not prove the and just assume the other one and continue on the other one. It's also the reason why I want to have implication as a primitive. So what we see here is that when we have things outside of the brackets, they are, give me a second. Sorry, I don't need this. Habits. Yeah. So what was I saying? I was saying that I lost my windows. Yeah. When something is out of the brackets here, it means they are not fully decomposed, and they can be decomposed without loss of generality. When you see a conjunction here, well, actually a positive conjunction, but we'll assume that all our conjunctions are like this. I can just have two hypotheses. So one thing that we may want to do, and I think I will eventually do, is keep at every step all the hypotheses maximally decomposed. But I don't want to decompose equivalences. Usually when you write an equivalence, you don't mean to use it as like left and side, like the pair of the two things. So with a caveat that equivalence, we might be better off at the end just writing them as equality, but it's a bit... Instead, I rather want to use them as a negative conjunction. So when I use an equivalence, I just say which one of these two sides I use. So maybe we can rephrase our automatic tactic as making choices in this, or some of them anyway. But at the moment, I think that's sort of where I'm heading. So at the end, remember there's a false that you use, like everything is disappears, the true disappear. And something that matters is that when a formula becomes a negative in here, they join the context, which I'm not sure. That must be this one. Yeah, the C here joins here, and it means it's either a negative thing or a positive atom. Because positive atoms can't be decomposed further, so they end up being here, if you have them. I've been talking for over 15 minutes, so maybe we should be programming. I'm guessing that I am more in the mood for speaking than programming, but let's just go back into the mood. So we were writing, no, that's the wrong file. No, that's the right file. So, we'll call that a fix. Don't print out tactic scripts. So we have this divisibility axiom which says if P is a multiple of M, then like it's N times M, then N is equal to T, the division of P by M, P divided by M, which could just as well be told as or said as if I take times n times m, and I divide it by m, I get n. Which is good and all, but with the current set of tactics that we have, we can't prove it. So what are we going to do? I've got two choices. Either we do what we said earlier, we'll just say, okay, let's just give us a way to crank, to focus a formula and to crank it. So we just copy verbatim the formula and just pass it a couple of things. I guess we can we can also, maybe we could refer to theorems by name when we focus them. I don't know. Or I could just define a specialized automatic tactic just as based on focusing. Which one's best? There's a number of things to do, really, to make this work properly. So one of them, if we do that manually, is to have a notion of a focusing stoop, as it's called, in the goals. One of them is to have a proper management of these variables when they're introduced. Well, not really this one. I guess that would be this one. Right now they disappear. I assume like I just assume that everything is in scope and I don't type check anything, so it works, but yeah. So eventually we'll also have to type check tactics. Actually, I haven't looked at why the order of things reverse when I have the order of the goal printout is reversed by these. What could be happening? Let's have a look at this while we're doing small things. And then I'll be late for the rest of what I'm doing, but it's fine. I think that I'll have quite a bit of cleanup to do, and today and the next time, which is in 2 weeks, presumably. Because all of these things that I've mentioned will soon be important. So let's have a look at this. When do we print out goals? I don't remember. Check program is where everything starts. Goal is type check proposition. This is the theorem that I'm interested in. So I'm type check the proposition. Mid P, and that is my goals. PP attempted goals, interacted goals. So that's apply mtag, that returns the goal in a wrong order. Evidently. Oops. When what do I do with apply mtags? Okay, let's apply tags. Okay, in my case, we have one goal. And so we're in this case right here. We do apply one. You apply one, returns apply tn tag G. So I need to find apply. Boom, 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 boom. Yeah. Okay. So prove with. What we're doing is so what we're observing is when we prove something, we say by induction, we don't say anything else. There are two goals and in the right order. But when we say by induction and we pass identity twice, they will appear in the wrong order. Oh yeah, because the no way. Yeah, no, I thought that might be because of the way I logged error, but that's not an error in the goal. It's just like it's missing. But so I run identity, get compose Google. I think it might be that it's really the dispatch function that reorder things wrongly. Because I never tried to compose something after them. I don't really have the tools right now, so I'm just gonna see if I can figure it out by just eyeballing it, and later maybe we'll get a taste of what's happening. So I'll get into compose vacuous error. Yeah. So dispatch. It refies the goal and then it calls runs it batch. So what is refi? It just takes a goal. But what is refi? Takes a tactic. Wait, what? Oh, because there's the first tactic. So I run the tactic with the refi, I think. It runs A on the goals. That's the tactic is called A. And then it just returns the sub goal of these tactics by calling eval on it. And so that's supposed to return my goals in order if my composition is written properly, which it seems to be. Well, the thing is, I'm calling failure on each of these. That matters. So it might also be the composition of this monad that is wrong. But I don't think so. Compose pure batch goal. Batch takes, it just makes a singleton for batch. I'll rewrite batch to be less well typed and easier to read, I guess. Close pure batch goal, eval A, yeah. That is the continuation. So on each goal, each sub goal, I will just call batch. And it's pure because we return something in the monad. So it could have been returned as well. I just said that it's not applicative though. And then I compose them together. Yeah, so that's just calling batch on everything. So I return the singleton for each of them elements. And then I immediately do a zip batch thing. So I take an A to FB and I call it successively on everything. Here it is. Yeah, I do the effect in the wrong order here. Exactly. But now I'm wondering why this is. This takes a list function, an L, which is this, and returns something of type. What? I mean, if the type is the only one correct, I don't understand the type. I understood it when I wrote it. I copied it over from something, but I still understood it when I copied it. I took the time. So this gives me... Oh, let's look at the type here. Right. The type here is that I have a batch that takes the next argument. So what I need to do is run these in the reverse order, which I think I can find. I can type. That's really inconvenient to type. In control applicative, I'm going to find the opposite version of this. Isn't there? Maybe there isn't. There's an opposed applicative though. I can call this. Oh, that's the one, yeah. Right. What I want to do here is f of x. That's a terrible notation for it. I'm sure this is going to fail. But my this OpenGC vterm is the vterm here. Vterm. Yeah, this is not affected by this. We'll have to rebuild it. The control applicative is there, so is it actually not affected? It is affected. Oops. Good. Okay, so we're gonna open the vterm here as well and return to the previous setup. Okay, this is fantastic. We can also do fix run applicative effects in the correct order in tactic in dispatch tactic. That's pretty pigeony, but whatever. Okay, so that's something solved. Now I can't really procrastinate anymore. What are we gonna do? I think I am going to implement this tube thing. That's automated, a small low level. I'm still not quite clear on what I want to do precisely. There's two possibilities. Possibility one, I add this tube to the goals, and I consider that functions that manipulate, or tactics that manipulate the goals are just regular tactics that just don't work when there's nothing in the tube and they just error out, which is quite possible. Another one thing to do is to consider it's like one thing that gives me all the choices. I'm gonna make them tactics. I think it's easier. So I'll have to add a couple of things to the goal though. Where do I define my goal? Oops, that's not gonna work. I've got two search engines. Accuracy is not compatible with alpha conversion. That's a good point. So one of the plan in the future will be to split the syntax in two parts. A concrete syntax that is produced by the BNF thingy, LBNF thing, an abstract syntax with De Bruyne so that I can test equality more easily. In the meantime, so now we want to say that a goal, less prop, thingy, and a maybe prop. Soon we'll want that to be a record, but I'm too lazy right now. And we'll do a maybe prop. Now, of course, everything is wrong. PP goal. Oh yeah, we might want to print a goal. So stoop. We'll make two cases. Nothing. We'll do that. And just stoop. I'm just should really take care of this printing thing so that it looks less silly, but it's just PP right now. PP stoop. PP. I need one of these. Oh yeah. Oops. Okay. Oh, by the way, I have decided that in the future, I should probably add Tante. Yeah. In the what? Oh yeah. Nothing. In the future, I'm going to add some background music to all of these. Oh. Okay. And I haven't done this now. I have an idea how to do this, but I haven't done this now for a few reasons. One of them is I'm not entirely sure how to give credits, and also that I've been busy dealing with my microphone. So in the future, there will be music. It's gonna be nice. So, 3 arguments. Induction, yes. I think that for induction, we should not be able to do it. If okay, that's not gonna work. Here I can add nothing everywhere. I think we kind of want to we might want to have two types of goals, like and define tactic on simple goals, and then like lift them to full-blown tactics when they for those that ignore the stoop and just assume that there's no stoop for them. And this will return a failure, which I don't remember how we do. But oh yeah, there's do fail of G. Nice. Interesting. Oh, because the type is, I'm supposed to turn this into attack again, I guess. No? I think it's good. It's just and 21 should have 3 arguments. We're going to do this all over again. Add an emps to. Yeah. Oh, there's a compose here. It is a bit annoying. Oh, I should actually do this. Yeah, that simplifies my life quite a bit. And I will probably have to check the type of do fail, because I think that's not the right one. So do fail, do file. Goal to attack him of A. And he says, so I kind of need to do compose as well, right? Fair enough. A few more. It sort of indicates that I can just do it after the case. So the compose. What is that with? No, actually, that's not going to change anything. Okay. I was going to say, let's put the case on the first line, but it's ugly and oops. And not particularly useful. Oops. I don't know. I'm not sure if I was right to be lazy was wrong. Next basic case expression in function application. Oh, that's just this. I think it's just because there's a type error here. Oh yeah, let's compose over here. Yeah, that's the reason. We'll have 3 arguments. What is this problem? Yeah, nothing. Yeah. And here. One is that we can't really do anything when there's a stoop except from doing stuff in the stoop. So I think that at the end of the day, we might want to have a bit more flexibility. It's a bit like, you know, just having a bunch of tactics that work out of the stoop and yada yada something something. There are still errors. Ah, I thought that was my last one. But of course it didn't. Two fail, I think is sufficient here. Of G. Fantastic. More. Yeah, this is very annoying, and I can't type. Nothing. Oh, wait, no, that's generic. So that is... do I have lenses ported? I don't have lenses imported. Probably should. That would have saved me a line. I just do prop terms of f and m stoop. Okay. Just okay. Term subsumption. I use guard, so this one is one that will not easily fail properly. But okay. So oh, that is exciting. I don't need the G either. And that's M0. Exciting indeed. And this one as well. Fantastic. We can compile again. Yay. I'm gonna call that a whip. Okay. So where are we heading now? So we want to add rules for these things here. Basically, I want to be able to select the formula, give it thingies there, or just thing is this part could be done automatically. I'm just going to call it anyway. So I'm going to call the tactics that gives a thing to that as with, I think. That will be with T. And this one, I need to name for it. That's all we're going to do with the current set of terms. I wonder if anybody has any opinion about whether we should use equality or equivalences for equivalences. I don't know yet. They mean the same. Eventually, soonish, I want prepositions to be a data type. Like in topos theory, prepositions are a data type, but proof of prepositions are not, even though they can somewhat be reified as by interpreting proofs as prepositions as subsets of the singleton set of the terminal element. You have to read them as like you can reify the preposition pay something like this. From the scratch thing, and you see P, a preposition can be reified as a set type object thingy as the set of X in the singleton. Let's go at unit such that P, and P doesn't bind X. oh, well, doesn't speak of X. So X is effectively a dead variable. So we can do that. You can then use a number of things like the conjunction, like you can take the product of two things and show that it proves the intersection, or the conjunction. You can use you have a squashing operator. From like, you can take a set and make a proposition out of it. Order reification is essentially a quotient by the total relation. Needs a bit of care to be able to reason about sets within that logic. But anyway, or to quantify over sets. But one is that you can do this. I'm gonna that's wrap. Okay. By the total relation, and you can see you can prove that sum maps to disjunction and cross product maps to conjunctions and things like this. You can prove them, and that lets you do some type theory things inside topos theory. But you don't need to. In fact, the proofs are not really represented as elements because a proof of P is just X if P is true. Actually, the proof is an outside thing, and that's what we're getting at with this system. I don't remember why I was talking about this, but it's interesting. Yeah, I don't remember why I was talking about this at all. I'm drawing a blank. Anyway, let's see if we can do some. Now we first need something to focus something. So I'm going to call the tactic focus, I suppose. It's a variant of have, but it puts the thing in focus instead of putting it in out of focus. It needs to have nothing in focus. So let's start with this. So focus 0. P, and we're going to take items. So we're going to do exactly the same as have and duplicate a ton of code. And we'll see later how to factor that. Focus 0 of pay. So that will start the same. So we have to copy everything because the difference is very slight. We just fail like this as well. There's a stoop, and if there's no stoop, this is still the first one, but we are not adding the hypothesis in front of this. The other hypothesis, we just put it in the stoop. Adjust. And this is really it. That's a very small difference. To do refactor together with have 0 somehow. No definition finding for me today. Okay. And now I do focus, which again, I'm just going to XR capital W. That didn't work. That is what? Okay, that works. That is not this. I don't remember how to cut a rectangle. Let's ask. Rectangle kill. Oh, I need to kill it with K, I see. And then paste it again, I guess. Okay. Here. Spend more time than I would have done with the mouse, but honestly, it was absolutely worth it. There's plenty of spaces. We don't care. Fantastic. Now we just have to add something equivalent to have called focus in my grammar of tactics. Where are they? Here they are. So I'm going to put it right below have. I'm going to call it T focus, maybe. Foxes, no. Focus, I'm bored. Focus, yay. Now I'm going to have a couple of places to fix. One. No fly check errors. Interesting. They're not configured with the same properties. Okay. So here I'm just going to go and copy have, call it T focus and focus. No, not foxes, focus for real. Yeah. Okay, now we can go back to the end. And we can go to our theorem where the first thing is id. But what we want to do is to take the axiom and focus it. So what we're going to say is focus. We're going to say the statement here. We repeat statements a lot, but it's fine. Repeating statements is usually okay. It makes things more robust, even though, because yeah, we'll see. Div by divisor. What's happening now? They don't appear in the order I was expecting, which is interesting. So maybe it's a bit different from have after all. In have, I wanted to prove, I proved first that it was sufficient. No, wait, no. No, have doesn't replace my, have just adds things in the context. Why are they reversed? That is weird. That is frankly unexpected. Did I mess things up more with my refactor of my fix of zip earlier? I don't know. But my understanding is this is, oh no, wait. Yeah, this one, yeah, okay. This is wrong. That's what I want to prove. Now it says I need the using thing didn't work at all, did it? Sorry, let's try something. What happens if I use, oh, sorry, it's just like it didn't give me an error, it just, still wrong, apparently, because I'm confused. Give me a second. have. So here I said there's a side condition, and that's my new thing is provable. And I say side k, so yeah. Well, that's good. Let me check something. Did it just flip? It's not super important right now. Well, that looks good. Yeah, that looks like it's the right thing. Yeah. Okay. Yeah, it was not good. Okay. Anyway, back to our thingy. Now we're starting to see the limits of having bad error messages. Understand none. We have no idea what's happening, nor even why these goals are in the wrong order, which is very puzzling. Something off has gone up. I don't know. I feel like it might be the fix from earlier. Let's go back to the tactics here and do this. Well, sorry. Let's just do. No, it doesn't affect that. That's for sort of reassuring. Oops. Okay. I don't know why they appear in the wrong order. This is really surprising to me. It is not at all what I expected. But apart from this, what's happening here? Here, there's been intros for some reason. Oh, that's nice. Okay. So what's happening is that my discharge tactic is a bit crappy. Okay, here it is. Because when I call this, oh no, I start by saying subsumption or max intros, but maybe subsumption is, I had assumption at some point. Do I still have assumption? Subsumption, assumption. I still had it. Okay, so we kind of need to start with assumption because assumption is sometimes stronger than subsumption. So discharge is assumption tactic, or it doesn't explain why things are in reversed order there. At the very least, have one fewer thing to prove now. Okay. So now we have this, and this is focused. So now we need a tactic to remove this n. I could do that automatically, but right now we're just going to provide the n to the thing. It's the first for all. Now we are bound to go back until there. Yeah, we'll have to figure out what we do. I don't think this is supposed to be negative. I don't know what if we should consider it negative or positive. So I'm just going to say that we're going to discharge this. So yeah, there's some iffiness. Like I need to check that some things hold. Like I'm not supposed to focus on something that is not negative. I can sort that out later because it doesn't affect completeness. It just adds more possibilities. So my point was, we are going to add a with tactic. So near to focus. Okay. Here is focus. Okay. We're gonna call it with tag here because, well, I'm gonna calculate with. It's not colliding with anything, I think. With, and it's gonna take a term and return attack. And that's a basic tactics. I just have no choice but to prove it. To do it with tactic.mark. Like everything I've done so far, almost. KG at goal hips and stoop concal. This one really needs the stoop. K's m stoop of. You can compose dollar here. Can do it here as well. Yeah, that's not going to work. Just stoop do. I had something, so I had a use and I had instantiate. Instantiate was here. Let's do something like this. It's just one, but we're going to do one at a time. So it's really thing about this is everything that happened in this tube is sort of one proof step somehow. That's why I was considering maybe I do it a bit differently. And I may eventually do that. Like a bit like the intro patterns in Coq, where we just give a bunch of intros at the same time, which sort of makes sense. I was thinking, yeah, maybe we need a stoop pattern thing. Then, like, some things get out of the stoop, something, yada yada. I don't know. So right now I'm thinking I'm gonna do the untyped thing, but like with the understanding that we're kind of stuck in this stoop, so I will need some shortcuts maybe. I don't know yet how it should look. So instantiate is the thing. It's just this, really, that I'm interested in. So ugly. So I will ask that to be a P for all. YP. There's a type as well. I don't need a type because I'm not checking it, which is wrong. Again, there will be a lot of places to come back to. I do that as well, yeah. That is my new proposition. So let's sub equals ghoul same hips. That's a just as well. Concall in Do I have one with the let sub? Here we go. Hey, that's almost all I need. Not composing. This is not looking good. What? Oh, I see. It was just stuck somewhere. Okay. Now we're going to add a with tactics. And that's a term. And that's all. $742. T width of you. With you. Okay. So now we can add our new tactic, which is with, so what do we want for n? We want it's soon going to be, it's going to be very, very bad. There will be a need of generating goals, a side effect, which either we do as new sub goals, and why not, like on top of the rest, or we do a bit differently. I didn't decide yet. I think we can do goals. We can add them on top. It's just part of, you know, it sort of makes sense for now. So what we want to say is we want a value for n, and n is the n is, I don't care what n is. What I'm interested in is p. So n is n, I assume. Okay. I'm going to put that only in a line with m and with div with times nm. Now why is there a conjunction? I'm confused. That was an implication. And that became a conjunction. Probably because the substitution into When did it become a conjunction? Here, probably. No. Why? I mean, honestly, why? Like, it's not like, okay, maybe substitution into implication is ill-written, but then I would have a conjunction here. But like, it's the third times I substitute into it, it just becomes conjunction. It makes no sense. How did that happen? Oh my god, I need to check. This is absurd. Honestly, though, isn't that the best part of programming? Wow. How is conjunction called? It's p-end. So we're gonna look for p-end, and we'll see one place where there's one too many. So that we type check a preposition. Okay, that is the comp arrow. Sure. That's O. We can check that. Oh. 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 That's funny. It's funny that we didn't notice before. I don't exactly know what happened, but if it happens an odd number of time, it will fix itself. Oh my god. Okay, this is looking more like it. So we can't assume, like in that case, it will be discharged automatically, but we can't assume it will be. And that's where having the focusing things tactics will pay off, because we're going to have two goals and we can just discharge, dispatch, sorry, not discharge, dispatch and use the Dawn tactic on trivial goal in that case, which is all good. But we need a name for that tactic. That gives me a proof of that. No, that asks me to prove that. Could be apply, I guess. It's a weird name, but it's sort of what it means usually to apply something. So, but we might also want, I don't know, to use apply for something else. Because, we can call it because, or since, or I don't know how to call it. Like with, and with. Maybe with is a terrible name as well. Naming is hard. Naming is like the hardest thing. I'll call it because. Which is what it is. Actually, no. I was going to call it because I wanted to possibly to discharge it on the fly immediately, but if it's not obvious, I'd rather want to go through all of them and could be pause. Yeah, in that case, I can discharge it immediately, but in general, I may not want to. So how do I call this? Impl. What would I say if I would say that? I have this and yeah. I'll call it premise. It's not a good name, but it's just a tactic. Not tac out tac premise equals tactic.muck dollar. Let me just copy this. Just a p impl pq equals let. There's not. I'm going to copy this, but it's not really assigned, so we're going to rename it. I also don't need to get compose. I'm going to have the sub goal first, because that's the one I want to continue on by default. We'll still have to dispatch somehow, but anyway. And well, I'm just calling it K side anyway. So side is I need to prove P, like it's written actually, but this one is Q. In all the cases, I just compose dollar to fail G. Still not working. Yeah, it's working. Okay. So now I'm going to do. I need syntax. Sorry. How do I call my tactic? Premise. Okay. That is not where I was going. I was going here. There's a T width, and then I'm going to do a T. Oop. Premise. This doesn't take any argument. Premise. Okay. Premise. The appear in the right order this time. I am so utterly confused. And this time I'm going to discharge the second one. So we're going to do this, id done, because the second one is true. What have I done? Okay. I don't have a single thing to prove. And I'm going to call that deactivate. Interesting. I don't type check my things, and the result is that nothing makes sense. Because I needed to call intros first, otherwise, dear Lord, that doesn't make any sense. What, really? Wow. I don't know when I did this. Look, when I intro an M, I add its side condition here. Isn't that fantastic? A good reason not to give it a name and to try to address things by name, because it's very non-robust. Good. I think eventually you might want to give names to things inside proofs to be able to refer to them somehow, and to be able to focus on something that has a name instead. This is something that is sometimes done in mathematics, let's call that property blah. I don't know how we will be doing this, but we might. For the time being, I want to go as far as possible without naming things, just to make sure that I'm using this as a constraint to focus the creativity part of all this. It's like when you have constraints, they help you do new things, and in a way, I want to avoid giving it to the laziness of calling things by their name when I can avoid it. And you might notice it's not that bad. I mean, like, the proofs here are a bit messy, but it's mostly because AC is complicated, and you could do much better in Cot with these because you can just do rewrite, but it needs a ton of setup, and we might get to some of it eventually, though I don't exactly know. It starts to be like that. For now, I just use a congruence closure thing. I don't necessarily want to add an arbitrary rewrite system thing that I don't know. I don't know exactly what I want. Could automate some of it. I just want to automate the obvious. So something like this. Anywho, now we need to deactivate. So I need this deactivate tactic. Near my premise tactic. Ooh. Deactivate. Let me cut sound for a second. Okay, I'm back. Deactivate. We need all this. We don't need this. We don't need this to be anything at the moment, so we're going to just make this be a proposition. There's a single subgoal, which is p colon hips. So in a way, right now, have is just focus followed by deactivate. So maybe that's what's going to happen eventually. Now, in normal focused proof search, you would not be able to deactivate something that is that can still be acted upon on the stoop. So if it's a negative, as long as it's a negative formula, it will stay there. And when you have something positive or a negative atom, because negative atoms, well, either they can immediately be resolved, or you just, I'm not actually sure. What can we, let's have a look. So when can I deactivate? Where are my deactivation rules? Maybe there's none. Must be there. So here we say that if we have an atom here and a negative atom here, then we can just solve the formula. But I guess we can give up somewhere, can't we? Can't we? Maybe we can't. Oh, here it is. It's called reaction. It's really deactivation. Oh, right, that's the right one. That's reaction left that I care about. Like, I have something positive here, or a negative atom. I'm pretty sure. Like, it's probably written here. Very small. P is positive and negative. C is negative from. Oh no. So okay. The decision of this proof set is that when it's positive, I can deactivate. If it's a negative atom and it doesn't go there, then I just don't take that branch at all. Where was it? I lost it. I lost it, but there was somewhere where I used a negative atom to prove something. Initial rule, that must be this one. Yeah, that one. Okay. And so that's the only way to get rid of a negative atom. So if there's a negative atom anywhere in your proof, like in the negative spine of your proof, of your proposition, sorry, it will only work if the right hand side at that point anyway, but it's probably what it is right now, is going to react with it. And so you're not going to focus on something eventually if it doesn't, if it leads to an end that can't be discharged, a negative atom. And all of these restrictions, they are only here to reduce the search space. They are fewer proofs. The entire point of a calculus like this. Am I showing the right? Well, you can't. Can you see it? Well, anyway, yeah. What am I pointing on that screen? I'm pointing right at the right direction, like this. A calculus like this has this property that you've removed a ton of possible proofs without removing any provable formula. That means, or provable secret. That means that's called completeness. It proves exactly the same thing as the original sequent calculus when you don't put any focusing restriction. But it has much fewer proofs, so a much smaller proof search is the idea. Potentially. Now, in that case, it just lets you backtrack, and it says, okay, I've got to that point, and there's no point in exploring that anymore. And of course, you can have heuristics that sort of detect this. You can see if you're getting in one direction and you know there's no point. You can do that. You can not select that. But basically, you're going to sort of, when you do decision, I'm scrolling for no reason. When you do decision here, you say, oh, there's this negative formula and I want it here as well. I want to select it and try to act on it. You're going to say, okay, I'm only going to do this if this is atomic, an atomic negative formula already. Or this will end up on a true or a false. You can and if it's atomic, you're going to look at this negative formula and you're going to look at the head of the formula, and you look at this as a pattern, and you might not be able to unify it depending on your logic, but if you unify it, it's better. Otherwise, you can at least see it's plausible to unify this with the head, and then you're going to proceed. But these are considerations that are a bit, like unnecessary for me. I need more proofs. I need many, many proofs, because many proofs means short proofs and a place for the mathematician to write things. So I don't really care so much, and I'm using this as a guide to help me formulate a number of things. And probably I'm going to automatically apply simplification rules that are not like rules like, oh, I see a conjunction, let's split it into, or I see a disjunction, let's make two goals. Probably only on the left though. Okay, I think this is not a catastrophe, but I have tea everywhere on my desktop. If only I have some contingency measures. Yeah. So that was what I was saying. It's fine to be able to deactivate any formula here. It's completely reasonable within the setting, I think. I was wondering if there's a P reaction here. Seems to be the same. This is quite fantastic though. Say that you're selecting the, okay. Oh yeah, if it's a positive atom. What happens if it's a negative atom? Oh yeah, negative gets here. Positive atom. Yeah. So here is interesting as well. Like you will decompose things only here only if there are some positive atoms to reach. It's quite fantastic that you can't put yourself in a bind by having like something like a negative conjunction. No, not here. Something selected. So here you have the positive conjunction of a positive atom and a negative atom. You kind of feel like if you have something like this, you can't really prove anything from the left because you end up with these negative atoms that need to be proved. And so you're going to get here a negative atom, here a positive atom. The negative one can be deactivated and you're good, but this one still needs to be proved, and you need to have exposed that positive atom here. It is not obvious at all to me that this is complete. It's quite fantastic, really. Wow. See, I had misunderstood this, and it looked much more reasonable. Like not obvious. It's never obvious to prove completeness of this sort of things, but like it's generally plausible. You say, yeah, I don't really need more, but here there's sort of race condition thing that. Whoa. Anyway, we're back to my other window, and I am going to. I just did deactivate. It's there. So really, I'm not going to. I'm going to here, and I'm going to try to add. Okay, T deactivate. I wonder how my keyboard sound. If someone wants to comment on this, tell me if the keyboard is loud or not. It's probably pretty loud. I've tried to muffle it a bit, but it's really, really hard to muffle these sounds, especially since the keyboard is actually closer to the microphone than I am. And also the clickiness happens to be in similar ranges, I think, than voice. On the other hand, I do personally find that the sound of a mechanical keyboard through a microphone is pretty satisfying. I kind of like it myself, but it doesn't mean that you would. And it's still like, it's... Why did I have to save both of these? So I didn't write it properly. And nothing, of course nothing. That was the problem. Good. 763. This one is getting pretty big. 151 lines. But by the way, you might notice that there's some like dark bands here and there. That's if you wonder why that is, there's a couple of reasons. First, the capture doesn't capture the window decoration. So anything like you would need a to have a full 16 by 9 window on a screen. You would need to deactivate this window decoration, but also use GNOME shell specifically, which has a nice layer. I have two small bands on top of my screen that are not displayed, and so that they end up as two bands of black that I put wherever I want. The way I could fix this is by not putting my Emacs full screen, but I must confess it's very inconvenient. Therefore, I just put it full screen for now. The browser is not full screen here, so here it just fills the entire space. Fun stuff. Where was I? Yes, I wanted to add tdeactivate here. And yeah, so it's a 1,000 line long. It's not that long. So here we are done with the premise, and we can now deactivate, I think. That's what I thought. Okay. What's happening here is that this is not parsed at the same level as the other one. Let me see what I did. No. Refined. Oh, this is fascinating. Okay, so what's happening is here I'm associating to the right, yeah, which is what I expect. And so this is a tax expert or level 1. What I can do is replace 1 by 2, call this 1. So it can be to the left of, oh, but do I want to actually associate to the left? Would that solve everything? I was going to ask what does cock do, but it is associative nowadays, so this question doesn't raise. And when I changed in cock the semicolon to be non-associative to be associative, it hardly broke anything, which is quite amazing. I was naive at the time, but it sort of paid off, so that's good. I don't remember how it used to associate. I think I expected to associate to the left, really. Like if I do semicolon, it applies to every goal that I've generated so far. So let me try something. So if I do tac expert here, that will break everything, won't it? Warning to shift reduce conflicts. Oops. Doesn't break anything. Now, the point is, I could parenthesize this here, but really, I would like to parenthesize thing when it's the other way around. I think. Now I put it here. Doesn't break anything. Good. Now I do deactivate. Brilliant. And now really it's just congruence closure, so we're done. Boom! We've proved something about division, which was my goal for today, and now I'm all disappointed because things work. There's plenty more to do, like being able to do this, like eventually like define the specification of like the full specification of division, which is somewhere off because there's the existential thing to be able to do, and hey, here's an interesting thing. Like right now, with only works when you have a focus, but we can do something very clever and say that when nothing is in focus for the purpose of the width tactics anyway, that makes sense in that setting, the right hand side is supposed to be focused. So instead of failing, we can look at an existential thing. It doesn't make any sort of sense as just wrapping two tactics in one. But really, because they do the same thing, calling them the same is fairly reasonable. The other ones don't really make sense. So like the premise thing doesn't make sense. There's no equivalent to this. And we will have disjunction, etc., that we can deal with later. Implication, as equivalence, I said I want to consider as some sort of negative conjunction. So there will be a choice. And I guess this choice and this choice could also be the same tactic, I suppose, for the time being. So what it seems to be leading to is that I have very declarative tactics until sometimes I focus on something and I can be a bit more imperative. But because what I focus on is explicit, the sort of imperative part is more is circumscribed, and I think it's well in the spirit of focusing, and I don't dislike that idea, to be honest. Soon we will probably make some kind of automatic focusing based proof search. I don't know exactly what form it will take yet, so I'll see. But some kind of, let's use a bunch of lemmas and just prove the thing. You know, you can apply things and try to finish everything with done. Basically, when we get to this sort of point. So here we kind of want to enforce the invariance, because otherwise it's going to be hard to prove. But whenever we get to something like this, we don't need n to be necessarily there, because you can just try, when we get to that point, instead of having this, we just say done or something like this. Okay, we don't have to, like, the proof is obvious at this point. I think it's more something like this that we want. And, you know, then some heuristic to select formulas in the right order, or to even, like, avoid formulas that, but I need to figure out first why this is even, like, have an intuition why this is complete, because otherwise I might do mistakes. Anyway, let's just make a PR real quick. Feat focusing tactics to work with implications. Sorry, Twitch just sent me a message on my mobile phone telling me, oh, by the way, you can use your mobile phone to manage your dashboard while you're streaming. What does that look like, by the way? Let's have a look. This is like, I've been streaming for 2 hours, but you know. Here it is. A bunch of things. They have activity feed, duration. I can see the chat. It says reconnecting to chat. Doesn't look very useful. I'm not sure what I'm supposed to do with this. Apart from read the chat. I don't know. I have no idea. Connecting. Welcome to my chat. Fantastic. Anyway, sorry about the noise. Focusing tactic to work with implications in theorems. Okay, now we're going to do some sort of right, we're going to go there. We're going to move that here, select this, like this. Hopefully everything commutes. Seems like it does. I just need to delete that line. Oops, delete, yeah. Fantastic, we have everything that we need. I can push this onto the branch. So now if I reload this, compare and pull request, focusing tactics to work with implications, theorems, create a pull request. There's still no CI, so we'll see later. But in the meantime, still in progress, convert to draft. I'm just managing it. So there we go. We have a pull request open. No, that was the same. It was just interesting. Okay. So now the prover thing starts to be a bit complete. Before I want to move on this, I think it's interesting. I think it is time to think about correctness a bit. Yeah. How do we want to do this? We'll need to expand goals. Again. This is going to be fun. Again. We're going to move back to the master branch and rebase the master branch. Here we go. Sorry. I'm very confused. it added my name on it. I don't know why. That is quite... I'm very confused. GitHub, you're doing things. Anywho, so are we adding hypotheses, like adding the literal so something to notice, by the way, before I move on, is we're going to put all the introduced names like at the same place. They are before hypotheses. And why is that? The reason is that even in intuitionistic logic, like in every logic, like this is just a bunch of implication, yes. And when you have no, that's not what I was looking for. I was looking for the scratch pad. So when you have something like A implies for all this font B, that is actually equivalent to for all X A implies B. And ignoring the interesting rendering of the for all quantifier by this font, the point is that we can always move them in front, provided we avoid capture, which I'm going to do in a bit of a silly way, which is to error out when someone throws a name that they already have in the context. I think a better way is something that I've implemented before, but it's just annoying to do right now, is to model shadowing of previous names by doing a renaming. And you always rename the old names because the new name is the one you are allowed to refer to. Like, it's a shadowing thing. You shadow the old name by giving it a random name that probably you should not allow users to speak of, but that the prover can. So something that prevents the parser from the name as they are parsed. So you can kind of want to have two namespaces for names, and they're identical, except that one of them appears as the result of the parser, and basically, and that's all. Okay. Okay. So that leaves you sort of ignore all things if you're not going to mention them. That's all. So we need to change the type of goals, and goals is starting to be a bit loaded. Hey. I think I'm going to change goal into a record. Because it really starts to be hips. The list of prop. 2. Maybe prop. Concourse. The prop. That's just probably already caused me trouble, so let's see. That's double colon in Haskell. Thank you very much. Right. So we're going to add a named field pun. We'll deactivate this button. Oh my god, does it do that? Oh, entirely? I didn't know that. That's interesting. The reason why shadowing is risky in Haskell is because everything is recursive by default. Okay. So I'm going to start with this. Heaps stu equals nothing. Congo. Stu equal just underscore. I think I'm going to use omlu soon to put some order into this, but I'm going to try to change most of these. That should be stop just to. That's also a table name for this too, because it's, well, I guess it's no worse than the other name field puns, I guess. I guess twice, that's fantastic. Sure. Okay. We took the, we decided to turn this into a record, and so I'm taking maximal advantage of the recordiness of these. Stupor. Okay. So it's actually slightly more verbose right now. Could like start importing lenses and generic lens, and we can do a bunch of things. That would be quite nice. I don't know why lens is not imported yet. I've probably used it. Like, is it in the Cabal? That is not what I wanted to do. I don't even know I have a Cabal project. I never used one of these. That was what I was looking for. Lens are here. So I use them somewhere. I'm pretty sure I use them in congruence closure or something. So they're quite available. I could use them. That would help with some of these. It will actually be very helpful to do it. Because soon I want to avoid, yeah, pretty much. I don't intro implications yet either. That's funny. I can do that in a sec. Soon I want to be able to talk about the right parts of the goals. They seem to start carrying some metadata. So nope. Yeah, actually. The point is I want to only modify the parts of the goal that matter. And the part that don't get modified, I should probably not. That must be exciting to watch. Refactoring. It's a thing. Here we're only changing the hips. That is kind of the point. Let me... we don't even need to use the conclusion here. Okay, we're almost there. 2 equals nothing. Concord equals P. We're really very close. Okay. Oops. I don't actually know which key I pressed to have that effect. See, now we're, you know, I was too fast earlier. Now we're not too fast anymore. That's good. We're more in line with what I hope to do, which is not a lot. I mean, as we are progressing through this, we're building up some vocabulary, and so refactoring becomes unavoidable. Stoop. Ah, that is good. I'm gonna call this stoop P. It's stupidity. Wow, that was worth it. Okay. This is great. Okay, so that's first refactor. I apparently haven't sorted them for a while. Oops. Yeah, that's sort of why you want like to set Omelu on your as an exit hook or something like this. To avoid this, like every time you commit Omelu thing out or something. I don't know. Omelu is nice in that it's really meant to limit the amount of noise in commits. Commits. I don't know how to pronounce this word anymore. Commits. Yeah. I think I said commits. Oops. But it's very similar. Is that the same word? Am I pronouncing both the same? Sometimes I hear different things. Refactor. Goal is a record type. Boom. Okay, now I am going to import control lens. I am going to in the cabal file. I don't need that. Can I? Imagine I once tried to use a multi-project cabal before giving up. I managed actually, because it looks like it has worked for a short time. Or maybe not. I don't remember. I wanted to go to the cabal file. And generic lens is there. Explicitly. That is good. Which is control lens generic, I think. Let's have a look. Oh, see. Generic lens. Boom. And that is data. Which one is it? Where do I start? Data generic labels? What? Okay, I need to go to the GitHub to be able to read the README properly. It's fine. That is not the same README. I thought that was the README. Ooh, I see. There. That link properly? No, it doesn't even have the... Okay, I think I need to go there, and there will be a README file. No? I'm confused. Where does that text come from? Available package, describe, table of content. Okay, I can read it. Okay, data person Sally. Field that name, yeah. But where is the... I know how I can do that. I can just click random place. Do field. I'm guessing it's one of these classes. They're in product. So I need to import data generics product fields. Oh, here we go. You just re-export everything. Whew. Okay, I get it. I should get more comfortable with that library. It's really good. I'm importing everything brutally. If it doesn't break, let me. Oops. Control lens use. What is that? I don't even know what that is. Let's have a look. Let's learn something. I think it's something to do with the statement, really. Stackage. Lens. So I have two choices. Either I import lens qualified, accept a couple of things, which would be reasonable, I guess, but it's a bit annoying. Yeah, use. Right, it's like view, but for the state mode ad, which is fair. Okay. So I'm just going to hide it for the time being. Hiding. Yeah. There's in the not going to use all of these ballistic symbols. I can use the dot hat maybe. So many. There is a way to, a nice way to emulate record update with lenses. I'm just trying to find what it should. It was based on the meta state really, but simple game of Pong. Okay. Use exec state, check bound. I'm wondering how I want to do this. One way is to just call over and set manually. Like, okay, let's call Haskell lenses record update. Well, let's see what the suggestions look like. Oh, there's maybe one in the tutorial. I'm not seeing it. That doesn't appear to be what I'm looking for. I remember there was something using the and thing, that is the reverse dollar. I think it's maybe even re-exported in lenses. When you don't do something, you just forget about things. The end. Oh, here we are. Oh, yeah, of course. It's just, yeah. Okay. I feel silly. You just called end, and that's all. That was 5 minutes, maybe more. Well, very well spent. Okay, so let's go through these again. My tactics. Okay. Oh, I forgot that one. Well. Which I can add to the other one. Also make refine slash scoping in goals. Here we're not doing anything special. Now that I can simplify this with the lenses. So I can just use tube here, and it's tube I can just do. Actually, I could already do this because I can do traverse. Ooh. Okay, that simplified a bit. Let's have a look here. Well, that's congruence closure, doesn't create new goals. Fail, fail, repeat, rinse. Oh yeah, I forgot to use add hip somewhere. Here, we say G and in. I'll check that end is it appears to be goal to goal. So over field at heaps add hip P. It's going to take a bit more room, but it's fine. The tube stays nothing and the conclusion is changed. And set concal field at concal p false. What's wrong? I need to have generate goals. That's fine. Data goal driving EQ and generate. Import gac.generics. And it's not used anymore. So we can remove this. I can remove this. Data functor identity is redundant. Okay, really because it's exported by something else. Okay. So here we are making a goal again, and that is G. And on G, we similarly on hips add hip constraint. Let's just copy it over. Over. And set concal to P. Parse error, eh? Why is this? Oh. I know what the problem is. And I elect not to care. Field concal. This is a tad verbose, but Let me use name field puns properly with lenses. I'd rather use that than make lenses. I think it actually also makes smaller files, so it's not bad. Actually, I can possibly use that to simplify some of my traversals I defined. I'm not sure because some of them are we'll see. I don't remember how a generic lens is. Like there's some type traversals, some of them are deep, and I need to figure out what this means. I'm just a bit scared. I can try them out later. Remove a bit of code would be nice. If we have more time, it's already pretty late. I'm gonna go on for like half an hour, 45 minutes, and then we're going to, well, maybe a bit more. Let's see, depending. No more than maybe an hour, something like this. Okay, here we also define a goal. And here, G, no, we'll put the end here. It's better. So over, and here I forgot to use add hip as well. Over field add heaps. I am going to do, hopefully this merges into a nice update, really. I'm not sure. But because everything is fairly, in that case, fairly evident, GC should be able to optimize away the intermediate forms. Not that it matters. Nothing is fast in this add hip of instantiate x prop with h. That's not one from today either. Not that it matters because it's probably not true. But let's, and the rest is nothing. That was nothing in conclusion, yeah? Yeah, I add an hypothesis. Yeah, of course, because it's used. And suddenly, I don't need hips, I don't need concal. Boom. Now it's become shorter. And more to the point. Have also defines things. Let's go. This one doesn't modify the hypothesis. If it doesn't define, it doesn't change the stoop either. It only changes the conclusion. It sets field at concal. And really what it means, I mean, I'm not doing like random shortcuts. It's really what it's supposed to be about. It's also supposed to be about tea, I'm sure, which I'm going to pour some more right now. I really hope the sound of my voice is good. It's really hard to figure out what would sound good in practice. And that's all. I just changed the conclusion. The rest is not affected, and that is kind of the point. Okay, and here we don't change the conclusion, we just change the hypothesis. Here we just, and also we forgot again, though of course if it's true, well, we can, in general, oops, it's over, over this. I'm gonna do add hip p, and says, oh, you don't need the conclusion or the hypothesis. Boom. another very short one. I know we'll be able to remove this tube later when we do this thing where we have the simple tactics that work on a simpler kind of goal. I will start requiring several files. I'll need to prepare for it. Induction. Here we're creating more goals. I'm not going to bother with this one because I've inlined the goals. Yeah, well, I may. Why not? We can do let in sub-zero. It's a Mortal Kombat joke. Sub sucks. For symmetry, let's do this. Equals. I can remove this because I can. Forgetting my chords. So that would be sub-zero. And this is what? Oh, I discovered a new chord. And that is sub-sucks. And it did something that I did with one extra chord before. So that is that's the goal G, except the conclusion has been substituted with an @0. So over, I don't know why I'm mispronouncing this word all the time today. You can hear my Frenchiness oozing. Subst prop x @0. Boom, brilliant. Yeah, okay. That is fair, dear computer and type checker. Okay, and here it's a bit more complicated. However, field add hips. So on the hypothesis, we do we add the conclusion. That sounds wrong. When we do the scoping, we'll have to get back to it. Let's remember that. Note. I'm going to write it down actually. Add hip. Actually, might. But no, it's wrong. Something is really wrong. Why am I adding the conclusion? What? Okay, yeah, I suppose it's true. It's what I'm supposed to. I am adding the conclusion. It looks like a bit of a hack, but it's actually looks correct. I'm shocked by having writing this, but it sort of makes sense. And the conclusion is substituted with successor of x. Oh my god, this is awful. And now we don't need the hips, but the conclusion is still used. Okay, more of these. Focus 0. Focus 0 will happen the same as in have 0. I think have should probably very quickly become focus followed by deactivate. because it does exactly this. Yes. So what are we doing here? Side is the goal G, where we have replaced the conclusion set field at concal with P, and sub is J, where we have set the stoop. To just P. And now we're using neither. Of course, we don't use the conclusion because this doesn't talk about the conclusion. And we don't use the hypothesis here because the only thing we do is enhance the field. We don't really need the content. Well, we actually don't touch the hypothesis here. We just touch the stoop. The hypothesis will appear in deactivate. Anywho, here is one more. That is so much fun. Okay. I don't know why a star appeared. I probably fat fingered my keyboard. So with just changes this to over field at stoop subs prop y oops you oh no, sorry, it's a set. Because we're really modifying it. We could abstract over this a bit more, but no, I think that's quite right. And the rest is left alone because it's a stoop only thing. See, we're gonna spare ourselves from talking about the conclusion and the hypothesis because it's something about the stoop, and so will premise be. So there's well, actually, this one is a bit more complicated, but just barely. Here, G, and so we keep the hypothesis, but the stoop is removed. So set field stoop nothing, because really in the sequence calculus, if you remember what's happening here, this rule here, nope, it can't display in total now. This just has hidden my top, but it doesn't matter. This is supposed to focus on the right, but I don't use a right focus because I'm considering that the right is always focused for that purpose. Right now, anyway. So I'm ignoring it. When we do some automatic proving, it might be so the concal is also set. Okay, and here we are doing the normal thing, the thing that acts on the stoop. So here we're modifying the stoop. Set field add stoop. Wondering if there are some fields, if there are some helpers anywhere that just defines lenses. Like it's just, oh, there's set field and get field. I think we can. Do they have over like things? No. Just defines over. Cute. That is true. Well, I guess I don't really want to use set field because it breaks symmetry with other fields. Look, we've gone through everything in like half an hour. Best worth half an hour of my life. I mean, look, it almost looks good. For something that I've almost entirely live streamed, I think it's pretty nice. Field P. We could have an update field as well. Right now, there's almost it's almost always just a field, so I could just give myself a few tools. Add hip P. That actually can be useful because that could be true. Also set field at sorry, that's hips, and that is stoop. What? And we say it's nothing. And now we can remove a couple of things. I think overall this increases verbosity a bit, but it will help us a lot with robustness in the near future. Yeah, another sort that I had forgotten to do. Factor, use a bunch, use lenses for goal update. I mean, I guess I could have used the record update syntax, but I went to lenses directly so that I could use over and so on and so forth. I haven't had to do much yet. Like you might have some times to substitute all the hypotheses or things like this, which will make me way easier using lenses. Lenses are generally useful. I'm just looking for other potential applications of lenses. So of course these they take context, so they are not readily represented as lenses, or like with the basic types in lenses. I wonder if I can replace a couple of PNs and P for all and P impol with this P end. That should be a P end. And on this one, let's look at P impol. These are just decompositions. That's good. This one is mentioned a lot. Oh, sorry. Yeah, I guess I would not change them during a substitution. But this one definitely. Which one was it? Yeah. Sun, mist, smart constructor, opportunities. There were prop terms, goal terms. Why am I using these? Which are not in the binder. Okay. Yeah, they're fairly... that's going to be hard to make into a lens. I have to detect that something binder something. Okay, let's forget it. I think we're done with refactoring now. So my next step was to add another context to goals. Which we are going to call bound variable. And for the time being, they're going to be what's I types. So it's a list of pairs of identifiers and an I type. Yeah. Okay. Now it's telling me I forgot about the types thingies. Which is fair. So now I also have the bound variables. I call them bound variables or bound vars. Bound variables. I may shorten it a bit. It's very verbose, but I'm not going to speak about it too often, so never mind the long line. How are we going to print the bound variables, really? Okay. Is there something for adding I'm gonna look by module name. Data text pretty print. It isn't in package? Was it just because there's a new thingy and nothing is, not everything? Data text pretty print. Yeah. Okay. Let's have a look at the Cabal file. That's pretty printer. Okay. I don't know the names of the things I use. Pretty printer. That one. Oh, that's so slow suddenly. Okay. So this sep thing. So let's have a look. Sep here, and we can possibly find. No, I don't think so. Sep family, cat family, punctuate. Filler functions, general convenience, plural, surround. And close. Okay. So let's say pp.unclose. I'm going to write it this way. And we are doing pp.punctuate. What is sep? Then that's not what I was looking for, but it doesn't matter much. Okay, so that's really I'm going to put sep here. I'm not sure. I need to learn the best practice with these ones. Punctuate. pp.comma bound variables. This one I forgot to the risk here is that if I add something, I won't be warned. Because in Haskell, contrary to OCaml, can I do this? Does that mean? Now there's a bug here, but I'm not sure what it is. Oh, I need to map pp. Yeah, I guess I was wrong. Oops, I need to take that out as well. And I really want to add this as well here. Oh, sorry. I think this will be wrong, but let's do that for the time being. We might have some context. We probably have some context somewhere, but pp pair print A print B to take a pair AB returns pair pp dot ansi style. I should have copied it over. pp pair AB equals PPA PPB. We could just actually that's wrong. That's a bad idea. Yeah, that is wrong. That is not what we want to do. So in a way they were right. PP bound var. It takes nident, not a mindent, nident, and a night type, and returns PPA pp dot plus colon pp dot plus pp dot b, and now I want to do pp bound var. I made sure it typed before I copied it over. Okay, now everything works. That was cheap. And this one is wrong, see? And that's a limited constraint. Bound vars in goals. So let's start with this. When I emit, so I'm in TCM, let's look at what TCM in is. Oh. Really? So now I need some bound context, which I get from something else, yeah. So I need Where do I call emit? Really, I should start with this. Not very often. And I have an eranv in both cases. It's true that this list is not particularly ordered. And an eranv. Do I have other kinds of envs? I'm pretty sure I do. There's an env, which would be more appropriate here, but we're going to use an renv because that's what we have when we call emit. We'll take an renv env, and we're going to do red bounds or bound vars. It's also a place where I didn't naturally write goal as a thingy. That's fine. Bound vars equals sorry, I spaced out. So my bound variables, so they will be env, toList, that's a map, right? Map.toList. And over traverse dot to, so on the second element of each of the list thingies, I want actually yeah, it's better. There's this thing about index traversals, but it's tricky to compose properly. Like, yeah, I'm not sure. Like, could do iTraverse, but then I'm not sure 2 would preserve the index. Fish it wouldn't. I'm not sure. Oh, we can try in a second. First we do that. Over traverse dot to. Luckily, I don't remember how to do to make a night traverse into a list of pairs. So I'm not sure. There ought to be a way, but right out of the top of my head, I can't. So I'm making it a list, and then I take the list and say, ooh, the number 2, I want to transform it from an R type to an I type. So let's see if I have a function like this. Type I type. That's underlying I type. Bound variables. I can just call it bound variables. I can use the puns hips equals given. I can say that this is hips as well, because I don't use it anywhere else. Stoop is nothing, that usually is. And concal is P. I can call it concal. Because I didn't mean to write this. Oops. Okay. So here we emit with the environment. Ooh. I don't have an environment. It's called env0. It's called tenv. No. renv. It's called env, yeah, it's good. Oh. Shoot, I just want the local ones. I mean, it's like within parameters, it's correct. I will need to make a renv capable of distinguishing local and globals. Apparently. Because the globals, they don't need to be there. They're just global. We can do that quickly soon. But first, I'm going to have a look at this iTraverse business. See if I can make something with this. Which is, no, that's not what I want to look for. So if there's something about list here. This is not very interesting. There's this. But is there a way to make a list with an index traversal? Folded. I2list exists. Okay. Let me try this. Let's be fancy a little. Emit. So it should not change the result. Sort of this. Well, that's not. I want to do over. No, wait. That's not what I was looking for. Here I just said. Oh yeah, it doesn't make a difference. Because what I wanted to do was like I do traversal and I do traversal. I do change on that traversal and then I do toList of this. But like even toList of takes a traversal. It doesn't take a change. If I want to do that, I need to change and to do the toList separately, I think. These are not like proper iterators yet. And there's no I2list of anyway. if I do I to list to list of, well, there's an I to list of actually. Where are you? Here you are. That's pretty nifty. I don't think I can do what I want to do in one step anyway. That would be nice. Like I just do, oh, I'm taking the traversal that just returns. It sounds like it could be a traversal, but composing a traversal and traversal, it's not completely obvious. Like I do traverse, and then I do what? I do I traverse, and that I get something, and then I want to say, oh, I'm modifying part of this as they come, which should be a getting, fair enough. But oh wait, actually, let's try something. So I can't write it this way, but let me so I to list of. I'm just trying to be fancy, really. I traverse dot. So now I don't need the two because that's the entire thing. So I just try to do two underlying I type. But that is not quite correct. I want it to remain like this, so I want to use one of these. I think that's the white one of env, and I'm going to import qualified control. Lines is very often that's good. So in that case, really, actually, I'm going to do something I don't like to do. I'm not going to, it's generic that I'm going to, that one. I'm just going to take the type class and the type class name only. Did I not even, I'm an idiot. Could have just copied things. Couldn't match index. Now I have to check which one is which. Ooh. Oh, that's an index with a non-index function. Could have kept this in the other order, by the way. This is I am not sure why that is. This would be I traversed. That keeps that one, yeah. Well, that's just because it's I traversed. That is the problem. Here we go. And we have the same list. So I got to be fancy, which I think is perfectly fine. It almost reads correctly. I mean, it's sort of obvious, but it really isn't. But it could be. It's the power of lenses. It's fantastic. Lenses are quite exciting. So now that we've done the fancy thing, we probably... I'm going to start with intro and handling intro right. And then we're going to remove the globals, and that's going to be it for today. But we will have to do some type checking soon. And yeah, currently there's something wrong about that too. Is that if there are several things with the same name, I might be out of scope. There's okay. So to do, there is a bug here in case of shadowing. We will probably have to implement shadowing probably. So I'm not going to bother in intros. I'm just going to do the intro, and I'll do the shadowing as well. Where one variable will appear to bind variables in hypothesis. What's the shadowing will appear to bind the shadowed variable in some hypothesis, yielding incorrectly typed goals. Boo! Incorrectly typed things. That's wrong. Okay, so that's something to remember for next time, because I don't think we will have time to do it today. That being said, by making the environment, keeping track of what is global and what is local, we'll be also able possibly to... No, actually, that's wrong. We don't care at all about... interesting. What happens when you shadow a global? Misery app happen because you can't mention it in types anymore. So shadowing a global will have to be forbidden by the type systems somehow. But well, we can just rename things then. Like we instead of if it's a global, when I'm shadowing it, I'm going to remove it, and I'm not going to remove it. I can't remove globals, so I'm going to change the name of my variable because that's done automatically, and I'm going to error out in intro. But in other cases, I'm going to change the name of the shadowed variable, which I think is more reasonable. And we're going to build that probably next time. Because it's late and I won't have time to do it today. Well, I mean, I've got all night, but if I don't sleep at some point, tomorrow will be horrible and the stream will be interesting. Yeah. Intro and then globals, and that will be all, I think. Okay. So this one, we need also, more importantly, field at bound variables. We do x colon underlying I type I don't know where this y came from, of toe colon. Boom. They are also in reverse order, so I'll have to reverse them. I'm printing random things that are not very readable right now. Okay, and now, of course, we haven't looked at intro anytime, but it probably should work. Where is there an intro? Intros here, which has a ton of roles. If I remove all this, just like this, I should really add mirrors at command syntax, and I go to plus sock, then I have indeed introduced all my variables and they're here. Good. To do shadowing. It's important to understand that we are not, like right now we say if it's a global, we're not allowed to use that name. Maybe more refined way is if it's a global that is mentioned, you're not allowed to use that name. This is tricky. I remember there's a number of bugs based on this. Like in Coq, there used to be bugs. There's this thing called section variables, and you were able to to remove any mention of them, add a new thing with that name, and match this with some local theorem. It was very, very interesting, and you could just get yourself into weird troubles that were hard to detect. It's fun. It didn't make Cog inconsistent. It was at the tactic level. Just to get an error that was at a random place that was inconvenient. Shadowing is fun. It really is. So we said distinguishing globals and locals, which will force me to make a data structure for the renv thingy. Let's renv. Okay, so since we're making a data structure, oh, it's just right next to the goal. It's funny. Why do I use it that often? Anyway, we're gonna make that a data, and we're gonna the thing is called the same as often in Haskell. This is a bad habit. We're gonna have the globals. And the local, and it's quite good to use a record because all of these have the same things. I'm going to look at how it's used, and oh yeah, oh, do I want to do it this way, or do I want to have the global and the locals and having a marker? Like it's instead of being an L type, IDOM maps to either global or local because it can't be in both. It's really, really wrong. So I think that may be it. That's maybe what we want to do, and so we can just make a new type instead. Because that just leave me with fewer opportunities for mistakes. Data localized equals a equals local of a or global of a. So that instead of a data, this will be a new type. Yeah. I'm gonna need this. Right, I can need this right away. And I don't want them to be R type, I want them to be localized. I want this to be generic as well. Localized R type. And we'll see very soon that this, so for this, I'm going to look through it. Maybe I'll make the traversal, I'll try it away, but for now I don't really need to, so I'm going to use field at renv, and I'm going to do this, and this will be the traversal. Yeah, exactly. And the point is that here we are going to use, so data generics field, I want constructor now, sum dot constructors. I don't know what any is. We can have a look. Subtypes. Woo. What's subtypes about? VL. Okay, yeah, there's a running example, but I don't know yet. So whoa. C node including type signatures. Interesting. That's the GAC hacking experience. Can be given below name of constructor whenever value. Oh, that is wicked. Anyway, that is not was okay. Interesting. Okay. I was just mistaken about what I was clicking, reading. That is constructors. It's the same example, interestingly enough. So is it CTOR that I need to call? I think I need to call CTOR. Yeah. Okay then. So here I want to call. I was not back on my thing. Okay, CTOR at local. That's the only one I'm interested in. Dot. Do I need to parenthesis this? No, that's not the point. CTOR is a prism. Can't apply expression of type T1. It's saying that basically it doesn't. Yeah. Okay. So what's happening here is that CTOR is not recognized and something weird is happening because it's a whole, and that's because I haven't done these data generic sum. Where am I? Where are these? Sum. That should fix it. Okay, good. Sort imports. Okay, whatever. So then, type, I will need to make new files to have qualifiers. So I'm taking a value. So right now I just want to get. I would love a submodule system right now. Data or new type renv. I'm going to make something horrible and say that takes a renv an ident returns an R type. So env bang x equals renv env project localized A to A. I want all these in modules. I wonder if there's a way to do this in a probably not as a lens in a generic lens. It might be. Actually, there's a single thing of that type on every constructor, but detecting this rather than detecting that it's a traversal is pretty hard. Renv env bang x map.bang. Interesting. That's too much. Okay, so this I can just do bang instead. I really want some modules. Insert. So that's add local. So it takes an ident, an R type, an renv, and returns an renv. Add local x2 env equals map.insert x toe, not toe actually, local toe, and add local. Okay, underlying I types. Rnv to inv. Map, I guess, or map.map exists, so let's do map.map of project localized followed by underlying I type to env. That's a global, so I need an add global as well. So this global local business is only marginally useful right now, but the localized thing, it will makes a lot of sense when we tackle shadowing. So that's an add global. We have a couple of these. We need the empty one. Yeah. We have a single one. This is just a definition that adds. Theorems should add. Oh no, they don't. They just add name things. I hate this name. I should be consistent in my capitalization. Boom. That is exactly what we wanted. And if I go to my last theorem, which starts with intros again, I can see that after intros, we have the M and the N. They're in reverse order, but that is fine. Okay, so now we can do the shadowing thing. We'll probably, to do shadowing, we'll have to consider the environment and the given as a bit of a single thing, because we need to shadow whatever we already know exists at the same time. So we'll generate a substitution. We'll apply that substitution to all the givens, I guess. Okay. do not still whip, do not include globals in contexts. Okay. I think this is all for tonight. So I'll write this to do next time. Have a proper shadowing semantics in the type checker. Shadowing must trigger renaming in the hypothesis, and renaming and when shadowing a local, shadowing a global needs to rename the conclusion instead, and intro shadowing a global, a local renames hypothesis, renaming a global is an error. Okay. That is not the only thing we're going to do next time, though I'm not exactly sure how we will proceed. They're all this business about existentials that we want to get into. Yeah, maybe a bit of automation. I don't really know. We're getting close to the time where tough decisions will have to be taken. Oh yeah, actually, to do next time too. Type checking tactics. That may keep us busy for a while. Okay, we're going to push this. Boom, so that we don't lose anything. Okay. So, this is getting almost clean. I would have to refactor, make more files to have namespaces and all. But it almost makes sense right now. Also, probably having these simple tactics work on simpler goals that don't mention the stoop is probably a good idea. So that because just there's so much repetition, so it would simplify the thing a bit, but it's really not urgent. It's until I'm annoyed by it. I will clean it up a bit, but the whole thing is starting to be correct. And yes, I'm not exactly sure where I'm going after that. I think so among the things that we need to do fairly soon is add a notion of definition, like not to have to axiomatize everything. Definition that could eventually be checked. Like right now, totality is just assumed in everything, so correctness is still interesting. But totality can be proved and checked for these things. And these definitions could also be compiled eventually. That's one thing. More importantly, this will let us, or more importantly, I don't know, like together with this, maybe orthogonally, really, is having propositions be terms of a certain type, which would let us define some things, like define orders on natural numbers, or define properties on, say, orders, having full-blown higher order logic. So that's good. And so these are things that are fairly immediate to do. And when that is done, I don't know, we can do a bit of Galois connection theory, a bit of order theory, maybe, to test it out. And I think that tackling quotient is starting to be a problem that will come up soon. Is it though? I don't know. Oh no, there are all the things. Yeah. Like we can start writing a few to-dos here. To do later. Propositions as terms of a particular type. To do later. Gonna want to transform these to issues at some point, whatever. Proposition system of a particular type. We said definitions. And oops. To do later. What was I saying? That's exactly why you write things down. What was I saying? Just a minute ago I was saying something and I don't remember what it is. Not existentials, that's sort of a next timey thing. Oh yeah. So adding for all R types would give us a modicum of dependency. A possible test is lists of a given length. Here we go. So, yeah, that's my thoughts for the future. That's quite a bit, actually. I'm going to commit this, and then I'm going to cut stream. Yes. So it's very late. I'm going to go to sleep. And so the program for the next couple of weeks, I'm still going to next week. I'm going to do some video gaming, and almost certainly like a Link to the Past randomizer in a version that we've already seen, quite probably although with glitches, because last week I noticed that I forgot a lot of things and I need to get back into practice. I'm still busy learning a ton of things on the side, and I'm not practicing video games all that much. In 2 weeks, we're going to come back to this with these shadowing problems and the type checking of tactics. And if that's not enough to fill 4 hours, we're going to do something else. But I don't know what yet. Probably existentials. At any rate, this is the end of this stream. I'm going to cut in a second. So see you next week or in 2 weeks, depending on what you're into. Thanks a lot for following along. It's always fun to share. And until next time, stay curious.